Okay, so for this question, we have 15% of the US population that has the recessive Rh factor negative blood type. In your MS1 class of 224 students, how many students would you expect to have each of the 3 possible genotypes? So the key to this question is just to write out what you know, right? So we have, we can first write out the formula. So it's p squared times plus 2pq plus q squared. And then we know that for each of these, like for example, p squared is representative of homozygous dominant, and then q squared is homozygous recessive, and 2 times p times q is heterozygous. So these are all genotypes, right? So the 15% of the US population that has the negative blood type, so that's talking about a condition, right? So therefore it's talking about a genotype. It's saying that 15% has this genotype of a recessive blood type. So therefore it would be 0.15 of q squared, right? So this is equal to q squared. So now we have to find all the other numbers, right? So starting from q squared, we can get q, right, is coming to this problem. We also have the other Hardy-Weinberg equation of p plus q equals 1. So starting from q squared, right, to get q and therefore getting the allele frequency, we just take the square root of q, and so square root of 0.15 is 0.387. And so from that, now since we know q, we can plug it into this equation, and then just plug it in, and then we get 0.682. So now we have the p and the q allele frequencies, right? So, but we still need the genotype frequencies. So for the genotype frequencies, we just take our p, right, and then square it, and then we'll get 0.375. For this one, we do 2 times p, right? So p is 0.682 times q is 0.387 would get us 0.473. So now we have all of our genotypes, right? We have the frequencies of all of our genotypes, and the actual question asked us in our class of 224 students, how many of each would have these genotypes, right? So now we multiply this by 224, each one of these by 224 to get our various numbers. So 84, 106, and 34. These are rounded up, right, because these are people. So based on that, we have these possible genotypes, and this is the answer we actually get. So this is how many people per genotype we have according to what they gave us, according to the general 15% of the US population. So I hope that helped, and thanks for watching.